Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on negative indices. So let's say we have something like 2 to the power of minus 1. How do we make sense of this? Most people think, oh, that would just be minus 2. It's actually not right. We can't multiply 2 by itself negative 1 times. You can't do anything negative 1 times. So how are we going to find out what this equals? Well, what we do, similar to what we did with the 0 power, is we define it so that it's consistent with other index laws. So I know, for example, that 2 to the power of negative 1 times 2 to the power of 1, so I keep the same base and I add the powers. Negative 1 plus 1 is 0, right? But I know 2 to the power of 0 is 1. 2 to the power of 1 is just 2. So I've got this equation here. So what I can do is I can divide each side by 2, and I get 2 to the power of negative 1 is actually a half. So this is just me proving to you 2 to the power of negative 1 is not negative 2, because that wouldn't be consistent with other index laws. 2 to the power of negative 1 is a half. By a similar argument, 2 to the power of negative 2 is 1 over 2 squared, or 1 over 4. 2 to the power of negative 3, you guessed it, 1 over 2 cubed. So you're seeing a pattern here. If you have 2 to the power of negative n, 2 to the power of a negative, it's just 1 over that thing, but you write it with a positive power. But of course, there's nothing special about the number 2. It would work for any number. So the rule here is if you have a to the power of negative b, that goes on the bottom of the fraction with a positive power. So let's look at some examples. Let's go ahead and simplify each of these 5 expressions. We'll write our answer in index form, something to the power of something, and only use positive indices. So let's look at the first one. So note, I had to say that b doesn't equal 0. You can't raise 0 to a negative power. You can't have like 0 to the power of negative 3, because that would be 0 over 0, which is undefined. So that's why there's b does not equal 0 there. So to write this in index form, using only positive indices, easy. We move the negative power to the bottom of the fraction and change it to a positive power. Now, if we look at the second one, we have a to the power of 3. B to the power of negative 3 is just 1 over b cubed. So I could just write this as a to the power of 3 over b to the power of 3. So what's actually happening is everything that has a positive power goes on the top of the fraction, everything that has a negative power goes on the bottom of the fraction, but you write it with a positive power. So that's a really useful rule for us to use in question 3. So we've still got our 1 over 4. P has a negative power, so it goes to the bottom of the fraction, but we write it with a positive power. Similarly, the R has a negative power, so it goes to the bottom of the fraction with a positive power. We don't need to write R to the power 1. Q, on the other hand, already has a positive power, so it goes on the top. So we have 1q squared over 4p cubed r. We don't need, of course, to write the 1 in front of the q squared. It's not that big a deal if you do, but I'm just going to get rid of it. So we have q squared, everything with a positive power goes to the top, everything with a negative power goes on the bottom. Now, question 4 is a bit different because we have a negative power that's already on the bottom of the fraction. So we know that k to the power of negative 3 is 1 over k cubed. So this is 1 divided by 1 over k cubed. Remember, when you're dividing by a fraction, you can flip the second fraction and make it a times. So it's 1 times k cubed over 1. And that's, of course, just k cubed. So this leads us to another discovery. Because of how negative indices work, if you have a negative power that's already on the bottom of a fraction, you can move it to the top of the fraction with a positive power. All right, let's look at the last one. So let's start by expanding the brackets on the top. So note, when we multiply these two powers together, we're going to get a positive. Because we're using the power to a power rule, we're also using the product of a power rule. Minus 3 times minus 2 is positive 6. And then y squared, 2 times negative 2 is negative 4. And then on the bottom, the 2 doesn't get raised to the power of 3, but the x does. And the y does as well. So let's simplify this. We've got x to the power of 6 on top and bottom. We can cancel it out. So we have y to the power of negative 4 divided by y to the power of 3. So we've still got our 1 over 2. You can just write a 1 here. Doesn't matter. Y to the power of negative 4 divide y to the power of 3. Keep the same base and subtract the powers. So now, of course, this has a negative power. We were asked to write with only positive indices, so we move it to the bottom of the fraction and write it with a positive power. How easy is that? All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.